doing some what's called changing the subject of a formula to express the letter in terms of the other. So example is, see the way in the first equation we have 2x plus y equals z, but it tells me that I want to get x on its own. So when this question is done, what should happen at the very end is I should have x on its own, and then everything else will be on the right hand side over the other side. So what we do is there's generally two tricks here, okay? You look at two sides of the equation. You look at the left side and the right side. Now, first of all, what we're looking for is x. X is on the left side. X is being multiplied by 2, and then y is being added on afterwards. So what you need to remember is multiplication is the closest thing to the x, which means it's the last thing that will move. So the first thing you're going to do is you're going to move the y over the other side. So you're going to get 2x equals z, take away y, because the y turns from a plus y. When it changes size, it turns to a minus y. Next thing you're going to notice is that 2 multiplied by x is left. Now, multiplication of 2 on the left, when you move the 2 over the other side, it should become division of 2. So it's going to be z minus y all over 2. I've now achieved x on its own like I wanted. Okay. Nextly, we're going to look at question 3. So we're going for 1, 3, 4, 5, and 8 to begin. Now question 3, it wants me to get P on its own. So it's PQ plus R equals S. First of all, the P is located on the left. It's being multiplied by a Q, and then R is being added on afterwards. Very easy for us to move the R from the left side to the right side. A plus R becomes a minus R when it changes sides. Next thing you're going to notice is it's P multiplied by Q. We don't want the multiplication of Q because we want P on its own. So we're going to bring down the Q. When the Q changes side, it turns from multiplication into division. So the answer is simply going to be S minus R over Q. Okay. Next question we're doing is question 4. Maybe you should try have a look at it yourself at this stage. Okay, so we get U plus AT equals V. Once again, we're looking to get T on its own. T is the star of the show. We want T on its own. Now, it's very easy to move the U over the other side because we can get V minus U equals A multiplied by T. Now, since we're multiplying it by A, when we bring the A over the other side, it's going to be division. So it's V minus U all over A. Okay, brilliant. Next question after that we're going to try is question 5. Once again, very similar. Question 5. Okay, we get 2b minus 3a equals 5c. Now we can see the b is here. So 2 multiplied by b. b is what we're looking to get on its own. So what we can do is we can make the 3a disappear to the right. So minus 3a on the left will be a plus 3a on the right. 2 multiplied by b, multiplication of 2 on the left. When you move the 2 over the other side, it must become division of 2. And there you go. So there is question 5 done. Next we're going to move on to question 8. Now in question 8, you'll notice question 8 looks different than the previous questions we did. In questions was a 1, 3, 4. What did we do? 1, 3, 4, and 5. There was no brackets. In 8 there is brackets, but what we can do is just multiply out the brackets. So a times b is ab, a times minus c is minus ac, and that will equal D. So what we can do first, guys, is now we have AB minus AC equals D. Now please remember we're trying to get the B on its own. Okay, so once again we can see that we're trying to get the B on its own, which is this B here. Well, if that's the case, we can move the AC over the other side, so we get AB equals D plus AC. A multiplied by B on the left. We don't want the A on the left, we just want the B only on the left. So it's multiplication of A on the left, which will make it division of A on the right. And there you go. Okay, so far we've done 1, 3, 4, 5, and 8. So that is 1, 3, 4, 5, and 8. Now you're going to notice in these questions here, the main difference is these ones have fractions in them. So if you ever see a half multiplied by 7, let's say 1 multiplied by 7 is 7. That's the same as 7 over 2. So a half of p would be 1 multiplied by p, which is simply p over 2. So what we can change question 10 into is p over 2 equals q. And we're looking for p on its own. There's two ways of doing this. Division on the left will be multiplication on the right. So we can say that p equals 2 multiplied by q. That's one way of getting the answer. Another way of getting the answer is common denominator. The q looks over and says, look, if I put a 2 on the bottom, I must have a 2 on the top. The 2's will cancel. P equals 2q. Done. Next thing we're now on to, guys, is question 12. Okay, so we've done 10. Now we're doing 12. Now, if you look across at question 12, we can see that we need a common denominator here. Okay, so what I suggest to you guys is that you put everything over 3, because you need the t to be on its own. So why don't we put a 3 under the s, which means a 3 above the s, a 3 below the r, which means a 3 above the r. Now you can see they all have the same denominator, and when they have the same denominator, then you can get rid of all the denominators. So that is 3s plus t equals 3r. Next thing we're going to do, guys, we need to get the t on its own. So we move the 3s from the left hand side where it's positive or plus to the right hand side where it is a negative. Okay, and we're good to go. So we've done 1, 3, 4, 5, 8, 10, 12. Now we're on to 14 and 16. Okay, so let's have a look at 14 and 16. So question 14 is p plus q over 2 equals r. In this case, we could give both sides a common denominator, 2 on the top and 2 on the bottom for the r. Everything's over 2, the 2 cancels. We're looking to get the q on its own. The q on its own being this one here. Well, the only thing stopping the q from being on its own is the plus p on the left. When p moves to the right, it's going to be 2r minus p. That's question 14 done. Now question 16 is the next part. So what we're going to do next in question 16 is we're going to have x equals y minus 2z all over 3, and we're trying to get z on its own. Well, first thing we do is get a common denominator and get the 3x and 3. Okay, the 3's will cancel. Next thing, bring the 2z to the left, so we get 2z plus 3x equals y. See the way it's a plus 2z now? We're quite happy about that. Move the 3x to the right, so we're going to get 2z equals y minus 3x. Then multiplication of 2 on the left is the same as division of 2 on the right. And then finally the z is on its own. The answer is z equals y minus 3x over 2. Alright guys, that is everything for this video. So we also did 14 and 16. Good job.